This is the third in a series of quarterly reports that feature progress being made by NASA's Exploration Launch Projects Office, which was chartered by the Constellation Program to develop safe, reliable, and affordable transportation systems for America's continued leadership in space. The Ares 1 crew launch vehicle will transport the Orion crew exploration vehicle to low Earth orbit for trips to the International Space Station, or to rendezvous with the Ares 5 cargo launch vehicle's Earth departure stage, which will transport the Lunar Surface Access Module and Orion to lunar orbit. The Ares 1 system requirements review and the Ares 5 first design analysis cycle were completed in 2006, both major steps toward America's return to the moon. The Orion capsule is equipped with a launch abort system that can quickly move the crew away from the launch vehicle in case of an emergency, greatly improving safety. The LAS is being jointly developed by NASA's Marshall Space Flight Center and Langley Research Center. The LAS Mockup is informing hardware handling procedures and integration, manufacturing steps, facility requirements, and logistics considerations, as well as helping train personnel on the system. This underscores the commitment to making operations more efficient for long-term sustainability. A simulated Orion command module and launch abort system will be used for the first test flight of the Ares 1 system in 2009, known as the Ares 1-1 mission. The Ares 1-1 mission will also use a shuttle inventory first stage to validate laboratory research and ground testing in real-world flight environments. A key objective is to develop and test a roll control system that will keep the rocket flying straight and on track by understanding the environments to which the new system will be subjected. An example of early system testing used a Viking lander thruster, similar to that which will be used on the forthcoming Mars Science Laboratory, to demonstrate the pulse mode operation of a 400-pound and a 600-pound thrust-class monopropellant hydrazine engine over a representative mission profile. The main objective was to determine if monopropellant thrusters are suitable for this new application in the continuing effort to reduce system complexity and simplify launch pad operations. Other tests have been conducted on the Ares 1-1 first stage roll control configurations using bipropellants. The highly instrumented modular model tester rig employs two valves that simulate the flow rate for 800-pound class thrusters. This system anchors analytical models, which are used to predict performance for the Ares attitude control system. The MTR demonstrates steady state and dual cycle feed system performance, including pressure transients, pressurization system performance for bang-bang, mechanically regulated, and blowdown systems, water hammer peak pressures, and priming pressures for feed lines, all of which are critical to flying an accurate trajectory. As part of preparing for its first flight in 2009, the Ares team has been investigating the Atlas Avionics, an off-the-shelf system that will be used on the Ares 1-1 mission. After modification, laboratory tests showed that the Atlas controller cards could, in fact, drive a space shuttle-derived actuator, which is a component of the thrust vector control system. Combining the latest in computer modeling and simulation with laboratory and high-fidelity flight testing provides quantitative information that assures design engineers that the Ares 1-1 vehicle will meet mission requirements, paving the way for a new generation of space transportation. The Ares 1-1 mission team is investigating the use of engines from the Peacekeeper missile for the test flight system's roll control. A Peacekeeper, which was in inventory at Utah's Hill Air Force Base, was shipped to the White Sands test facility for decommissioning. The hardware has been modeled and laid out in a CAD environment, so the engineers can plan for its use in the new application. One of the main things they want to determine is the roll torque to complete the preliminary design of the Ares 1-1 system. This is an example of how three-dimensional mock-ups and flight hardware planning is enhanced by virtual reality computer applications. It is also a novel way to get early flight testing by using existing inventories that can replicate the new system. Moving from computer simulations to three-dimensional wind tunnel testing is another step toward obtaining real-world flight test data before the system goes fully operational. For the integrated Ares 1 vehicle, over 2,800 wind tunnel runs have been conducted, some using pressure-sensitive paint. This valuable information helps engineers make design decisions much earlier in a traditionally long process. This testing is generating data to understand the Ares 1 force moment and pressure results for the guidance, navigation, and control system, trajectory, loads, and aerothermal performance as inputs for the second design analysis cycle, which will lead to the preliminary design review in 2008. Viewing computational fluid dynamics results in comparison with three-dimensional wind tunnel data is one way that confidence in empirical models can be verified, as new aerodynamic databases are established. This methodology has been instrumental in double-checking the integrated loads results generated by CFD. Results to date show accurate comparisons. Analysts work closely with technicians, making real-time adjustments based on results. This novel approach to using proven methods in new ways has created synergy in the process, where the sum of the outputs is greater than the individual tests alone. The Ares 1 5-segment reusable solid rocket booster first stage builds on its heritage from the Space Shuttle's RSRBs. However, this proven propulsion system has never flown in a single-stick configuration, so various items are being reworked. For example, a new forward frustrum, aeroshell, modified parachute recovery system, and forward skirt are in various stages of development and testing. Avionics and electrical systems are being developed concurrently with other Ares elements. The Manufacturing Work Center builds the flexible bearings that enable the nozzle to gimbal and steer the vehicle. Case cylinders are mated to form a factory joint before insulation layup, propellant casting, and painting. The propellant grain pattern also is being redesigned for a higher burn rate that will enable the vehicle to move more quickly off the launch pad. Important information was obtained during a rare nighttime static test firing of a Shuttle solid rocket motor in November 2006. While primary objectives were for the Shuttle mission that flew in December, the motor was outfitted with sensors to capture data for several Ares tests that were performed during this opportunity, emphasizing NASA's commitment to flying its present transportation system safely and to maximizing important tests such as this for its new launch vehicle systems. When the test article's 1 million pounds of propellant was ignited for the 2-minute burn duration, measurements were taken to define motor-induced roll torque from internal combustion. NASA's Engineering Support Center is analyzing how the motor affects the rotation of the first stage as a key input to the Ares 1 roll control design. The Ares 1 upper stage is a NASA design that will be developed by industry. Again, modeling is a tool that assists engineers as they optimize the blueprint to meet specific mission requirements with robust design options. Industry benchmarking lessons learned show that hardware mockups are indispensable to manufacturing and operations teams who need a tactile feel for the equipment. Following that standard, the instrument unit has been mocked up to provide insight for designers, manufacturers, and launch processing teams as they strive to improve efficiency and provide cost-effective solutions. Component layout and interfaces, internal environments, and ground support equipment concepts are being analyzed well before the hardware manufacturing begins. In November 2006, the Stennis Space Center officially turned over its storied A1 test stand from the Space Operations Mission Directorate to the Exploration Systems Mission Directorate, beginning a new chapter in its long historic role in space exploration. The 158-foot-tall stand, site of Saturn V stage testing in the 1960s and Space Shuttle main engine testing from 1975 until September 2006, was temporarily decommissioned to convert it to test NASA's J2X engine, which will power the upper stages of the Ares 1 and Ares 5 launch vehicles. The stand is undergoing refurbishment and modification to begin J2X power pack testing set for late 2007. Work in the fourth quarter of 2006 also saw the disassembly at Stennis of J2 heritage turbomachinery used during the testing of the X-33 linear aerospike engine power pack in the late 1990s. The equipment is undergoing block upgrade design, analysis, and long lead procurement for power pack assembly testing in 2007. This evolved turbomachinery will combine heritage thrust chamber, gas generator, and more from the Saturn and X-33 programs with new materials and designs to provide greater performance, safety, and operability. This early testing provides valuable information and experience for test stand operators, technicians, and engineers. The progress being made on the Ares 1 first stage and the J2X upper stage engine have direct applications to the follow-on heavy lift Ares 5 system, since this is common hardware. The Ares 5 is in the early design phase, with preliminary analysis work performed against anticipated mission requirements. Several technical trade studies have refined the early concept as the team works to take the vehicle design to the next level over the months ahead, while leveraging lessons learned from designing the Ares 1 launch vehicle, which will be delivered first.